Today we're going to discuss a very important problem named maximum subarray, which I think most of you might have heard with a different name called maximum subarray sum. Why this is important and why this is popular? Because it consists of a very popular algorithm named Kadane's algorithm, which is a very interviewer favorite algorithm and has been asked many times in interviews. So let's jump into the problem statement right away. So we are given an integer array nums in which we have to find a sub-array with the largest sum and we have to return the sum. Right, sub-array is basically part of the array. So what we have to do here is we are given an array and we have to find a part of the array with the largest sum. So it's a pretty self-explanatory problem statement. As you can see here from the given example, from this given array, the sub-array 4 minus 1 2 1 will have the largest sum. Right, and similarly for 5, 4, minus 1, 7, 8, the largest possible sum you can get from is basically the entire addition of the array. So now let's move on to constraints. The maximum constraint we are given is 10 raised to power 5, which cannot be solved in n square, which needs to be solved in, I think maximum time complexity for this can go as high as n log n, I think, yes. So again, uh, we're not going to talk about the bogus brute force approach, which is just uh, reiterating through the entire element one by one and storing the maximum sum, and then again iterating to the next element, and then iterating to the entire array and find the maximum sum, and so on. Right? We're gonna move on straight to the approach which the interviewers look for when they are being said write the solution in form of Cardin's algorithm, right? So we're gonna talk about the explanation and the code side by side so that you don't have to look at the code later and have to relate with the explanation, right? So you're gonna look at both of them at the same time. So I've taken an array this, as you can see. Now this array we'll start iterating it one by one for a single element at a time, and also I'm gonna explain you the approach behind it. Right. So basically, initially, what happens in Kadane algorithm is we maintain two variable. One is the current sum and one is the previous sum. The current sum at every index store the sum at a particular index till that index, right? Basically cumulative sum of till that index starting from 0 till whatever index we reach. And previous sum is the basically maximum sum that has been achieved till now, right? So we have to maintain a track of these two variables at every single index, right? And also there's an important catch that whenever our current sum reaches less than 0, we have to convert it to 0. Now, this is the most tricky part where most of the people are like, why do we do this, right? What if the entire array is filled with negative numbers and we just equate it to 0 and we might get a 0 in return, right? Which would be wrong. So I'm going to explain you why we put the current sum to 0 whenever it reaches a value less than 0. So, right, we'll get into the explanation. Starting from index 0, which is minus 2, the sum would be equal to minus 2, right? At 0 index, sum would be 0 plus minus 2, 0. So our current sum value would be what? It would be minus 2. And similarly, since the previous sum we have taken from the smallest integer possible, so it would be minus 2 again. For this, right, the previous sum and the current sum both would be minus 2. And here you can see, since our current sum is less than 0, so we'll change our current sum from minus 2 to what? To 0 now. Now our current sum is 0. Updated current sum is 0. Now moving on to the next value, next index value, which is 1. So here you see, if we have not made our current sum minus 2, right? If we have made if we have not made our current sum to 0 from minus 2, then here the sum would have been minus 2 plus 1, which would be equal to minus 1, right? But now you see the importance of making 0, right? As there can be a sum, there might be possibility that in this entire array we might get a sum, we might get a maximum value of 1 only, is that this integer 1. But that would not have been possible if our sum would have been minus 2, right? If minus 2 plus 1, at this point we'll reach minus 1 as the maximum value, but that would have been wrong, right? The maximum value here should be 1. So I think this might give you a hint why we have put it to 0. Okay, but let's move on. Uh, there will be multiple examples regarding this in further indexes also. So 0 plus 1. Now our current sum would be 1, right? And our maximum previous sum would equal to 1. Now let's move on to next index 1. And since our current sum is not equal to 0, then we'll skip this step. So moving on to next index, it would be second index value minus 3. So 1 plus minus 3 would equal to minus 2, and maximum sum would still be 1, right? And still again our maximum sum, our current sum is less than 0, so we again convert minus 3 to 0 again. So now moving on to the next index, which is 3 index, we get 4. So now our current sum, since we have set it to 0 in the previous iteration, so in this our current sum would be equal to 0 plus 4, which makes it equal to 4, right? And similarly, the now the previous sum, which is the maximum sum up till now, it would be equal to what? 4, right? And again, we'll skip this step because it is greater than 4. Moving on to next index, which is minus 1. So 4 minus 1 would be equal to 3. Previous sum won't change, and current sum is greater than 0. Moving on to 2. Now the current sum would be equal to 5, right? Our previous sum will change to 5, and current sum again won't change. Moving on to next index, 1. 5 plus 1 is 6, right? This would be changed to 6 as well, and again current sum won't change. Now moving on to next problem, uh, sorry, next index, 6 plus minus 5 would again change it to 1, and then 4. So we get the just now that the maximum value we'll get here up until now is 6, right? So I hope you get the reason why we put it to 0, because if we have not done that, then we might have why we might still carry the negative value from the previous indexes, which is not needed, right? Because the maximum value which can be attained if it already negative is the next index value, because again the maximum subarray, a subarray can be of single integer only. So and as you see, it passes all the test cases also, and this is O of n approach. So this is what Kadane algorithm talks about, and this is the pretty much the easiest code I could find for this logic. So I hope you get the gist, and if you didn't get what I'm trying to explain, just watch the video again, and it's pretty good example and pretty good code explanation. So I hope you'll get it, and I really hope you like the video. And yeah, do smash the like button and subscribe, and I'll keep posting more videos like this in future also. So thank you for watching the video.